Have you ever watched one of those just mind-blowing acrobatic drone videos and asked yourself, how on earth do they do that? Well, the secret isn't just in their skill. It's actually in what they see. So today, we're going to go inside the pilot's goggles to break down exactly what's on their screen.
So what is an FPV pilot really looking at? You know, it's not just a video feed. It's this incredible mix of reality and raw data. I want you to picture a live first-person view of the world, but with a heads-up display plastered right over it, almost like something out of a fighter jet. That's the thing we're going to decode today.
And to pull this off, we've managed to get our hands on something really cool, a transcript from an actual FPV test flight. It's kind of like having the pilot's black box recorder. It totally reveals the secret dashboard of information that they are constantly relying on for control, for safety, and for navigation.
All right, so here's our flight plan. First up, we'll peek inside the goggles at the display itself. Then, we're going to decode all those crucial indicators on the dashboard. Everything from flight modes to the fine art of watching your battery. And finally, we'll see how it all comes together once the drone is in the air.
Okay, so let's step right into the pilot's point of view. The real magic behind all of this is something called the on-screen display, or OSD for short. This is the piece of tech that projects all that critical flight data directly onto the video feed. And what that means is the pilot's eyes never ever have to leave the sky.
So now let's start decoding this digital dashboard. You can think of it just like the dashboard in your car. It's packed with all these essential gauges and indicators. This information gives the pilot total situational awareness. And believe me, without it, a pilot is flying completely blind. Probably the most fundamental tool up there is the compass. It's usually sitting right at the top of the display, and it shows the drone's heading, north, south, east, west. If you're trying to navigate, or more importantly, get back home, this is absolutely non-negotiable. And our flight transcript actually shows this in action. The pilot makes a note that as he rotates the drone on the ground, the compass on his screen moves in perfect sync. It's a simple check, but it's a perfect illustration of that real-time connection between the physical drone and the pilot's digital view.
All right, next up is a really critical safety feature, the arming status. When a drone is armed, it means its motors are live. One tiny touch of the throttle, and those propellers are going to spin at thousands of RPM. Disarmed means it's safe. It's really the digital equivalent of a safety switch on a power tool.
And right there in the transcript, one of the very first things the pilot does is arm the drone and then verbally confirm that the arm indicator has popped up on his screen. That is the final go signal before takeoff, confirming the drone is hot and ready to fly.
Now, flying an FPV drone isn't just a simple on or off situation. Pilots are actively choosing between different flight modes, and these modes completely change how the drone behaves. It's this constant balancing act between automated stability and just full-on acrobatic freedom. And we can actually see the pilot making this choice in real time. In the transcript, he calls out switching between modes, going from angle to air mode. This isn't some automatic system. This is the pilot actively changing the drone's entire personality right in the middle of a flight. And the difference between these modes? It's like night and day. Angle mode is basically your safety net. It's self-leveling. So if the pilot lets go of the controls, the drone automatically rights itself. But air mode? That gets rid of the safety net completely, giving the pilot total acrobatic control for those insane flips and rolls. But it demands constant, tiny adjustments just to stay airborne.
Okay, this next part is, I would argue, the single most important skill for any FPV pilot: managing your power. The battery readings on that OSD are your digital fuel gauge, and if you ignore them, your flight is going to end very, very abruptly.
It really all comes down to knowing your numbers. Our source material confirms that a fully charged battery cell reads about 4.1 volts. You can think of this as your full tank indicator right before you take off.
Now, on the other end of the spectrum, the pilot knows that if any one of those cells drops to 3.3 volts, a low battery warning is going to start flashing on the screen. And that is not a suggestion. That's the signal to bring the drone in for a landing, like right now.
And get this, pilots are actually tracking two numbers at the same time. You've got the total voltage for the whole battery pack, but the real pro move is watching the per cell voltage. This shows you the health of each individual cell, because if just one cell dies, the whole drone can come tumbling out of the sky. It's a critical safety metric.
So we've decoded all the data, but if you listen closely to the transcript, you start to realize something else, something really important. All of this technology doesn't exist in a vacuum. You see, the flight isn't just one person and a machine, it's a conversation.
I mean, just think about everything the pilot is juggling at once. They're monitoring the compass, the arming status, and the flight modes. They're keeping a close eye on 2 different voltage levels. But at the same time, they're also talking with people on the ground and navigating a real-world environment. The mental load here is just immense.
And that, right there, might be the biggest insight from our source material. It's not a silent data log. It is a conversation. You can hear the dialogue, the directions, the teamwork. The pilot isn't alone. They're working with a spotter, planning their next move. It just goes to show you that high-level FPV flight is so often a team sport, one that's built on a foundation of trust and clear communication.
So it kind of leaves us with this question. We've seen all the technology and the data, but when you have to process all of that in a split second, what human skill do you think matters most? Is it just lightning-fast reflexes? Is it the ability to multitask under incredible pressure? Or maybe, just maybe, it's that clear communication we heard in the transcript. It's definitely something to think about the next time you see one of those incredible FPV videos.